Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today I am joined by Eva Thanheiser, who's an associate professor in the Department of Mathematics and Statistics at Portland State University. Eva, thanks so much for being here.
Very excited to be here.
We are going to be talking about Eva's article with Kate Mellowish that has been published recently in the journal ZDM Mathematics Education. That's in volume 51, and the article is entitled Leveraging Variation of Historical Number Systems to Build Understanding of the Base 10 Place Value System. So we're going to get to talk about some place value and some number and operations in elementary kind of settings and make some historical connections there, Eva. It's a very intriguing article with some really cool figures and historical connections. But you've listened to the podcast, I know, so I want to first start, as I usually do, by getting a little bit of background about yourself. So, Eva, where was it that you went to grad school, and then what was the focus of your dissertation back then?
So I went to grad school in San Diego at the joint program between SDSU and UCSD. And back then, all the literature had come out that prospective teachers and teachers can do algorithms in math, but struggle to explain why they work. Mm-hmm. And so I was really intrigued by that. It was really curious to me how you could do the algorithms but not explain them and why that would happen. And I was about to do a dissertation on helping pre-service teachers learn about those things when I started reading and realized that we don't really know how pre-service teachers think about number. And that's what ended up being my dissertation, is the step one in working with somebody on learning something is figuring out how they're thinking. Mm-hmm. So I figured out how prospective teachers think about number. I came up with a framework. And the main findings were that, for example, in a number like 423, many pre-service teachers think about that as a 4 next to a 2 next to a 3, and not necessarily as a 400 plus a 20 plus a 3. Right. I just actually replicated a lot of those findings, and that came out in Jeremy last year. Mm-hmm. So if anybody's interested in that, that's in there.
Yeah, and it's been nicely updated. That's great. Who was it that you were working with and advising you back then?
I was working with Randy Phillip.
Oh, okay, great. So there are some connections here to the current ZDM article, still thinking about the base 10 number system, and also this idea of not just being able to compute and operate with numbers, but to have an understanding of those numbers. So I was wondering if you could just expand upon that a little bit more. Like, why is it so important to think about the meaning of our base 10 number system, and not just, like, why isn't it enough to just be able to compute efficiently?
Yeah, so there's a difference, right, between doing operations like addition, subtraction, multiplication, and division, and really conceptualizing a number. So if we go back to like the 423 I was talking about, thinking about that as 4 100s, 2 10s, and 3 1s, or 400 ones, 20 ones, and 3 ones. That allows us to pull numbers apart and work with them. So for example, when we want to add numbers like 18 plus 13, we can pull those apart and say that's 10 and 10. That makes 20, and 8 and 3, that makes 11. And so 20 and 11 is 31. And to really explain later on in algorithms why we regroup numbers or how we're able to do that, we need to be able to understand how a number is composed, rather than just being able to read off a number of a paper.
Mm-hmm. And how do you see prospective teachers fitting into this? Like, why is that an important population to examine more closely about this understanding issue?
Yeah, so that's really important for pre-service teachers and teachers to be able to explain, for example, why when we add two multi-digit numbers, we write those little ones up there, because they're going to be teaching children. And if they can't explain why something works, then we'll perpetuate this vision of math just being a bunch of rules we have to memorize, rather than math being something that is logical and understood.
Yeah, and I think there is definitely that connection to explaining the algorithms and why they make sense. I think also having a deep understanding of the number system helps teachers be more accepting and going with the flow when students have divergent kinds of ideas. Like if students are trying to do things in different ways, a teacher with the understanding of the number system can look at those and make sense of them and then know how to move forward with it and receive it positively rather than like forcing all the students to do it in a single way.
Most definitely. And that is kind of where we're going these days, right? We want students to make sense and work problems the way that makes sense to them rather than using a prescribed method. Mm-hmm. There's actually also a third thing we could talk about is, for example, if you think about 12 times 15 and you try this problem in many, 4th, 5th, 6th graders, they will answer with, 12 times 15. Okay, I'm doing 10 times 10 and 2 times 5.
Oh, sure.
And my answer then is 110. So this leads them to not quite understanding how to operate with numbers, which lays the foundation really for almost all mathematics later. Mm-hmm.
So let's shift right to the ZDM Mathematics Education article. And we're already talking about the sort of motivation for this article, but what's the specific goal that you had for this article in particular?
So one of the things that makes working on understanding numbers really difficult is that almost all students that come to us are experts at calculations. They can get the answer right. And so figuring out or relearning that is very difficult because why should they, right? They can get to the right answer. And everything is really complex. So when we're little children, we learn how to count and we learn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so forth. We never stop to think what makes 10 a different number from 9. And for children, it isn't. It's a collection of 10 things or 11 things. But 10 is very different from 9 in the fact that in our place value system, we make a group of 10, and then we can look at this as 110. And, as we move on to 11, 12, 110 and 1 ones or 110 and 2 ones, but simultaneously it's also 11 ones or 12 ones. So all of those things are very hidden. So the goal of this particular study was to figure out a way to make the things that are really not visible, visible. And one of the theories I'm using for this is called variation theory. And so variation theory posits this idea that it's only by comparing something that is to something that it is not is that we really can figure out an understanding. So seeing like numbers only in base 10 makes it very difficult to understand base 10. But if we move beyond base 10 and compare, that'll allow us to isolate features like grouping, place value, and base. And so the idea here was, let me figure out different historical systems that elementary school teachers have to learn anyway. Teaching about the Egyptian system and the Mayan system is part of the elementary school curriculum. Let's leverage those to make visible some of these properties of the place value system. Mm-hmm.
And so in the article, the core of the article, you have this local instructional theory that you developed with your co-author, Kate. But I wonder first if you could just tell us about what is this idea of a local instructional theory. People are very familiar with instruction and they're familiar with instructional sequences and things like that. But what's this specific idea that you have here of a local instructional theory?
So a local instructional theory has both. It has a theory about the process of learning, and then it has a means to support that learning. So in our case, we build on variation theory and intellectual need. So not only do we vary things, but we also create a need for really focusing on the thing we want students to focus on. And I'm going to give some examples of that later. Mm-hmm. And a local instructional theory has 3 phases. You prepare for it, you implement it, and then you analyze. And you go through these phases over and over and over, and each cycle kind of informs each other. So each time you enact a task, you kind of look back at your theory and see, does your theory still explain the learning? Do you need to tweak something? And then you kind of create a task again or a task sequence, and you kind of go through it again, and it's this back and forth. Mm-hmm. So it's a bunch of, if you want to think about it, it's a bunch of like teaching experiments back to back to back, maybe, that are all based on a certain theory, and then you just kind of inform it back and forth.
I'm speaking with Eva Thanheiser from Portland State University about her article in ZDM, Mathematics Education. So now with that kind of backdrop, I think it's a good time to talk about the actual local instructional theory that you developed. So can you tell us a little bit about what was that sequence and what were the ideas that you put in place to actually try to work on this base 10 place value system through comparison with other number systems and things like that?
We have three features that we isolated as important in our place value system. And one was the fact that we actually have a grouping structure. So we group in different group sizes. We have the ones, the tens, the hundreds, the thousands, and so forth. And if you want to go the other direction, the tenths, the hundreds, and so forth. Mm-hmm. Then in our system, the size of the group is decided by the location in the number, right? Mm-hmm. So we decide the ones is on a certain space and the digit next to it on the left represents how many tens we have. So the space in the number tells us the group size. That's the place value. And then we're actually having a group size that's based on base 10. So we always group by tens. Mm-hmm. So these are the three features that we wanted to highlight and then fuse. And so the first thing we did is take all of them away. And we gave students a bunch of tallies, and I have in my article a picture of that, and there's 500 some tallies, and they're somewhat misaligned. And the question is, how many tallies are on this paper?
Yeah.
And so students have to work through it, and they get very frustrated, and they I've never had a class where they all came up with the same number, so there's a lot of miscounting going on. And so they become aware really quickly about this need for grouping, right? Mm-hmm. And so they end up grouping the tallies into either groups of 5 or 10 or 20. And then once they started grouping, the counting becomes much easier. Mm-hmm. So this notion of the tally system and the need for grouping highlights this feature of grouping. Mm-hmm. So then they usually invent their own grouping first, where I also have pictures in there where they have stars and moons or whatever they call the different groups. And then we introduce the Egyptian number system, which is a grouping system. So the Egyptian system has different symbols for different group sizes, and they also group in groups of tens, but they also have groups of 5s and 50s in there. Mm-hmm. Now, as we introduce the Egyptian system has the grouping, so it's easier to write down large numbers and it's easier to communicate, but it's not a place value system. So calculations are very difficult. So then we have students do a multiplication problem in the context of the Egyptian system, and they become very quickly aware of that this system is not working for calculations well.
Again, there's an intellectual need now for the next part.
Exactly. So there's a need for some kind of place value or some kind of system that allows the calculations, at which point we introduced the Mayan system, which is a place value system, but a base 20 system. Okay. And so now they have the place value, but now talking about grouping and regrouping between place values becomes difficult because they're not used to thinking about in base 20, right? Which we have like the 20 and then the 400. So as the different places. And that makes it very clear that, we can't just or if we write that little one, it has a different meaning now as we regroup. Yeah,
and we don't have enough numerals either, right? Like on our keyboard or on our phones, we don't even have enough numerals to be able to do that very easily because we're not built for that currently.
Exactly. So that's kind of the basic idea. And this is like a several weeks long sequence of tasks. So obviously I can't tell you all of them here, but the idea is to just leverage these historic systems that are interesting and part of the elementary curriculum anyway. Now, I want to note that this isn't a historical recreation because they're different cultural systems, right? The tally system, I think, existed everywhere, but then we hop from the Egyptians to the Mayans and then to the base 10. So it's not a linear historical progression, but it is historically kind of how number systems progressed. They went from tallies to groupings to place value.
Mm-hmm. And what I like about it, too, was I could imagine a sort of a nice lecture where somebody would just lecture through these different things. Like, I'll tell you the problems with the tally system, and then I'll tell you this other one that has grouping, and then I'll tell you the value of a place value system. But what you do with your, what you developed for your LIT, you really get the pre-service teachers into it. Like, you give them problems that they have to try to solve, things they have to try to do so that they can actually experience the intellectual need, they can feel it. And to me, that seems so much more potent than somebody just telling you the value of grouping, for example.
Yes, and I want to just say that this is something that took years and years and years of fine-tuning and trying out tasks. So there's 2 years of data collection presented in here, but there's a lot of longer of trying out and fine-tuning tasks in here. So this isn't something that you can just quickly kind of figure out. So what exactly works in creating this need for students? How do you pose a task so that they kind of get frustrated enough and say, hey, this doesn't work.
But not too frustrated that they just want to get rid of the whole thing.
Exactly.
So in the article, you share a little bit about what you've seen from the prospective teachers, like the kinds of learning or conceptual understanding that they have after this sequence of tasks. Also, you've been doing this for years. So even maybe beyond the article, I was wondering what you could say about what you've observed of prospective teachers when they've done this.
Yeah, so we did multiple kinds of data collection here. We just scanned everything, all their activity, but we also did a pre and a post assessment, and these go back to my dissertation framework, where we kind of just analyze students' conceptions as they come into the course and as they leave the course. And one of the things that happens through these activities is that they really start developing an understanding of the number system, and that, if I have my 423, the 4 isn't just this digit that I write there as a 4, but it actually has a meaning. It represents a group of 4 100s. And then I can even rethink those 4 100s as 40 10s or 400 1s, and then flexibly go back and forth. Now, not everybody always understands everything. I haven't figured that one out yet.
You mean it's not perfect yet?
It is definitely not perfect yet. But I think most students come away with a different way of reading numbers. And one of the examples I've started using is that if you think about the word cat, right? It's a C and an A and a T next to each other, and you put them together and it makes cat. And similarly, a 4 and a 2 and a 3 next to each other makes 423. But that doesn't yet mean that you actually understand all the underlying features and relationships, because there's way more to this 423. And so I think we, working through the sequence of tasks and other tasks just helps students uncover more. And I think you can't do this really fast. That's the other thing. When I did my dissertation, one of the questions was, so what? So they don't think about numbers the way we want. Can we just tell them? And one of the things we've learned is we can't just tell them. It's really a long process to learn about numbers and to figure out how all the pieces relate.
Yeah, and the fact that you've been working on these ideas since your dissertation, and then you said it took years to develop this LIT, I want to ask you about what you see as your next steps in this work. What's the next thing that you're trying to tackle?
Yeah, so I actually have done a slight turn. I'm really still very interested in the prospective teacher content courses. And I'm still working with numbers. I'm also working with fractions, all the different content areas. But I'm currently really interested in bringing in more of a social justice context, so that we learn the math as a means to make sense of the world rather than for the sake of learning math. And so currently I'm redesigning these courses with respect, what you said earlier, is one of my main foci in this numbers course, is to think about all the different cultural ways that students add, subtract numbers. And it's a little bit easier for me because where I come from, we use different algorithms for several of the operations. And so I often just throw that up there and say, so what do you guys all think about this? Rather than saying, no, this isn't a good way, you have to do it the way we do it in the US. We want our teachers to really be able to learn how the students are thinking and maybe how their cultures or their relatives taught them, and highlight that as valuable rather than dismissing it as not the way we want to do it. And so those are kind of the directions that I'm taking right now in these courses.
Eva, at the end of these interviews, I usually ask people what they would do as an alternative career, but I'm going to kind of push you in a certain direction because maybe you would be a broadcaster in your alternative career. I want to talk to you a little bit about the podcast that you are working on. This is a mathematics teacher-educator podcast. I was wondering if you could just tell us a little bit about your involvement and what the scope of that podcast is.
Yeah, so we just started that with the last issue that came out in September 2018. Every article that was published in that issue now has an accompanying podcast to go with it. The way we do the podcasts is we have a somewhat preset set of questions, and then we adapt them to each article. But the idea is to give the MTE audience a different way to consume the articles. And, none of us have time to read all the articles in all the papers. But this could give us a quick 20-minute introduction to, what the articles are about. So we can listen to this while we're driving to work or doing something else, and then decide whether we want to read that article and still have kind of a sense for all the articles that are in there. So the editorial board has decided to go ahead and do a podcast for each of the articles that comes out. And we, as I said, so far we have one issue, and we're working on the second issue right now.
And how have you been enjoying it so far?
Oh, it's been great fun. It was very nerve-wracking for me. And my friend and colleague, Ziv Feldman, was kind enough to be my first guest. And we recorded the whole podcast. The MTE panel listened to it, decided they want to change the questions. We had to re-record the whole podcast.
Oh, yeah.
And so he was very kind to do that with me. But now I think we have a structure we like. And it was something that the panel had decided that we really want them all to follow the same kind of structure so that it's a quick view into the article, like what we did, but that you really, if you want to know more, that you then go get the article and read it.
Yeah, absolutely. I always hope that people who are interested go get the article because there's always more details, more nuance and things there. But it's definitely, like you say, being able to listen to some, it at least expands the horizons to more than you'd be able to read if you actually had to take time to read everything. So I do appreciate that. And so the plan for the Mathematics Teacher Educator is to just continue with the issues and to try to hopefully get every article represented on the podcast. Is that right?
That's the plan right now. We'll see how it goes.
Yeah, and what's the easiest way for people to find it?
So I think we have 3 places to find it. One is on the MTE website. There's a website, mtepodcast.amte.net, that has all the episodes on it as well. And then once you listen to one episode, you can just subscribe through iTunes or Google or whatever your way of listening to podcasts is.
Yeah, that's great. I was just listening to the episode with Ji-Young Yi, who's a graduate of our program, and so that's really great to hear her when she was talking about the emergent bilinguals and issues related to that. So that's really good. I've been enjoying listening to as well, and I'm also very happy to have more people taking this on because there's so much good research in math education. There's no way one person or one podcast can cover it all. So I feel like it's great to have the Math Teacher Educator Journal kind of covered on your end. So I really appreciate that.
And you can probably figure out where we got this idea, right?
Well, no, it's great to see it, and I'm enjoying listening to it. And Eva, thanks so much for speaking with me, too. I really enjoyed the conversation.
Yeah, thanks for having me.